Welcome to the spoken tutorial on inclined plane. In this tutorial, we will demonstrate inclined plane app. Here I am using Ubuntu Linux OS version 16.04, Firefox web browser version 62.0.3. To follow this tutorial, learners should be familiar with apps on physics. For the prerequisite tutorials, please visit this site. Using this app, we will demonstrate the motion of a load on an inclined plane with constant velocity. Calculate the resolution of forces. Let us define an inclined plane. An inclined plane is a flat supporting surface tilted at an angle. It has one end higher than the other. It is used for raising or lowering a load. Use of an inclined plane provides greater mechanical advantage. Examples of an inclined plane are ramps, slides, stairs, water slides, and others. Use the given link to download the apps. I have already downloaded Apps on Physics to my Downloads folder. After downloading, HTML5 folder appears in the Downloads folder. Double-click on HTML5 folder. Now double-click on the FEN folder. In this folder, we see apps in JavaScript and HTML format. We will use the apps with HTML file format. To open inclined plane, press Ctrl F keys simultaneously. In the search bar, type inclined plane. Right-click on inclined plane _en.html file. Select the option Open with Firefox web browser. Inclined plane app opens in the browser. This is the interface of inclined plane. The green panel shows different parameters that we can change. Reset button on the top of the green panel helps to edit values. The yellow Start button is a toggle button for start, pause, and resume. Slow motion checkbox is used to observe motion steadily. Then we have spring scale and force vectors radio buttons. By default, spring scale is selected. Click on Start button. Notice that the load is pulled by the spring scale. Click on the Pause button. Now select Force Vectors Radio button. Observe that there are 5 arrows pointing in different directions. We can change the values of angle of inclination, weight, and coefficient of friction in the white color boxes. Note that these values can be changed within certain limits. Click on Reset button. Here we can change the angle of inclination from 0 degrees to 90 degrees. Let's change the angle of inclination to 45 degrees and press Enter. Now click on Start button. When the load reaches the middle of the inclined plane, click on Pause button. Notice that the pink vector shows the force of gravity. It tries to pull the load towards the center of the earth. The blue and red vectors are the resolution vectors of gravity. The red vector is perpendicular to the surface of the inclined plane. The blue vector is parallel to the surface of the inclined plane. If theta is 45 degrees, then this angle is 90 degrees, as it is perpendicular to the surface of the earth. From the triangle's geometry, this angle would be 90 minus theta. To calculate the magnitude of the forces, we need to know theta value. Now these two lines are parallel, and if we assume that this line is a transversal line, then angle 90 minus theta is equal to this angle through interior angle property. Recall that red vector is perpendicular to the inclined plane. Here, the angle would be 90 degrees. Let us assume this angle as x. So, 90 minus theta plus 90 plus x equals to 180. Therefore, x equals to theta. Using basic trigonometry, we can resolve the parallel and perpendicular components. Consider this right angle triangle. Here, the blue parallel component is equal to the black line. Parallel force is sin theta. Sin theta equals to F parallel upon mg. Let's rearrange the equation. F parallel equals to mg sin theta. Similarly, we can resolve the perpendicular component. F perpendicular equals to mg cos theta. Let us solve this numerical and verify the answers with the ones shown in the app. Click on the reset button to reset the app. In the app, change the values according to the numerical. First, let us convert 1.02 kg into Newton and enter the value in the weight box. Next, change the angle of inclination to 30 degrees and press enter. Now click on Start button. Again click on Pause button when the load reaches the center of the inclined plane. Observe that the app has calculated the parameters. Next, we will calculate using the formulae. Calculated value of the parallel component is 4.99 Newton and that of normal component is 8.65 Newton. And the necessary force is equal to the parallel force but in the opposite directions. Let us compare the answers with the ones shown in the app. Observe that the calculated values are comparable to the measured values. Let's observe the effect of friction. Click on the reset button. In the coefficient of friction box, type 0.5 and press enter. Click on the Start button. When the load reaches the middle of the inclined plane, click on Pause button. Notice that the black vector is added to the blue vector. This vector represents force of friction. In the green panel, force of friction is measured as 4.3 Newton. Notice that the necessary force required to pull the load has changed to 9.3 Newton. This is because the total necessary force is sum of parallel and frictional forces. As an assignment, solve this numerical and compare our answers with the ones shown in the app. Let us summarize. Using this app, we have demonstrated the motion of a load on an inclined plane with constant velocity, calculated the resolution of forces. These apps were created by Walter Fend and his team. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops and gives certificates. For more details, please write to us. Please post your timed queries on this forum. Spoken Tutorial project is funded by MHRD Government of India. This is Himanshi Karwanje from IIT Bombay. Thank you for joining.